As Cassini orbited Saturn and explored its many secrets, one of the mission's most groundbreaking components detached for a mission of its own. This was the Huygens probe, a lander developed by the European Space Agency, ESA, specifically designed to explore Titan, Saturn's largest moon. Titan had long intrigued scientists. Covered in thick, hazy clouds composed of hydrocarbons, it was a world of mystery. Beneath its atmosphere, some speculated there could be liquid lakes, methane rain, and even a subsurface ocean. But no one had ever seen Titan's surface up close, until Huygens. The probe itself was compact, only about 1.3 meters wide and weighing 300 kilograms. It was carried by Cassini for nearly 7 years before finally separating in December 2004. Once detached, Huygens drifted through space for 22 days before reaching Titan's atmosphere. At this stage, Huygens was essentially asleep. It was designed to conserve power until the moment truly mattered. A wake-up timer activated the probe just 15 minutes before atmospheric entry. And when it awoke, it was showtime. What followed was one of the most dramatic and scientifically rich descents in the history of space exploration. The descent through Titan's atmosphere lasted 2.5 hours. During this time, Huygens deployed multiple parachutes to slow its fall, beginning with a small pilot chute and progressing to a series of larger ones. This allowed the probe to remain stable and collect as much atmospheric data as possible during its descent. Its instruments sprang to life. Huygens measured the atmospheric pressure and temperature, wind speeds, and the composition of the gases surrounding it. For the first time, humanity had direct data from the atmosphere of a moon more than 1 billion kilometers away. But perhaps the most breathtaking moment came from its camera system. As Huygens descended, it captured images through the haze, gradually revealing a landscape that looked oddly Earth-like, complete with river-like channels, dark lake beds, and highlands. Yet instead of water, Titan's surface was likely shaped by liquid methane and ethane, flowing and evaporating much like water does on Earth. The probe didn't just float down, it landed. And not just any landing, a soft, successful touchdown on Titan's frozen terrain. The surface temperature was a frigid 179 degrees, 290 degrees, and yet the probe functioned for over an hour on the ground before losing contact. For the duration of its descent and surface operations, Huygens sent data back to Cassini, which then relayed it to Earth. The timing had to be perfect. Cassini had to be in the right position above Titan to receive the signals. A narrow communication window that worked flawlessly thanks to careful planning. In total, Huygens sent back 350 images and a wealth of atmospheric and surface data. It showed that Titan has a thick nitrogen-rich atmosphere, the only one of its kind among known moons, and that its surface features are shaped by seasonal changes and methane-based weather cycles. This descent, this one moment of contact, fundamentally changed how we see Titan. No longer just a blurry orange sphere in Cassini's images, Titan became a world, a real place with terrain, weather, and potential for astrobiological interest. Scientists now believe that under Titan's icy crust lies a global ocean of liquid water, kept warm by tidal forces and possibly containing the ingredients for life. The data from Huygens continues to influence future missions, including NASA's upcoming Dragonfly rotorcraft, which will explore Titan's surface in greater detail. Huygens was a triumph of international collaboration. While Cassini was led by NASA, the Huygens probe was built and operated by ESA, proving that space exploration transcends borders. Together, they achieved what no single agency could have done alone, landing on the most Earth-like world in the outer solar system. The legacy of Huygens is profound. It didn't just touch down, it touched human curiosity, scientific imagination, and our eternal quest to understand alien worlds. In the next segment, we'll return to Cassini and follow its continued exploration of Saturn's moons, from icy Enceladus to the chaotic surfaces of Mimas and Dione. These moons turned out to be far more dynamic than anyone expected. Stay with us at Infinity Beyond as we continue the cosmic journey.